Oh yeah, there's pages on this one. Yeah, so it's on page 2 in this unit, in your notes. Yeah, in your coiled book. Okay, so we're going to learn about some, you're going to want to have your formula sheet out most likely. Where? There's some in the back, at the back. Yeah, look in Math 3-2 at the back. There should be some formula. And if you have your formula sheet on you, guys, if you open up your formula sheet, so grab it. I just want to point you to where we're looking in this unit. Guys, who's talking? Okay, if you need a new formula sheet, there's some at the back. Open. Oh. Okay. It's blue, like everything else in our course seems to be. Seems to be the color of choice. So your formula sheet looks like this. Okay? So far, there's nothing really we referred to in this unit, or this year, but what's new is going to be logical reasoning. Okay? And so this is the exact formula sheet you're getting for your diploma exam. So that's what you want to get used to. This is the one you're going to rip out your little booklet and you'll have in front of you. And so these symbols we're going to learn about basically everything except for intersection and union today. So we'll talk about complement, the empty set, and the subset. Okay, so that's what we're going to learn about. So if you are writing your diploma exam, you forget what different things mean, there is this little legend there to help you. Okay? So going to our map of Canada, social studies here. Jasmine is studying the provinces and territories of Canada. She has decided to categorize the provinces and territories using sets. So I'm going to just use abbreviations, right? BC will write BC, Alberta will write AB. And so this is the map that we're going to refer to. So what's a universal set? This is the first definition. Usually universal set, they use U for universal set, kind of ironic, no? A set of all elements under consideration for particular content. So we're going to write in this case, it says list the elements of the universal set of Canadian provinces and territories. So how we list a set, so this one set is going to be called C for the universal set of Canada. And we have to have our squiggly brackets when we open up a set. We're going to list all the provinces and territories. So let's use the abbreviations. So what's the first one? BC, comma, AB, comma. Let's list them all. Okay, you have the maps up there for your SK. Okay, so we have BC, comma, AB. Then we keep going east, Saskatchewan. Manitoba's MB. Then we have Ontario. Anyone know what that is? ON. Quebec. QB. New Brunswick. NB. Nova Scotia. NS. Prince Edward Island. You should all know this one. PEI. Yeah, Newfoundland and Labrador. We're just going to use Newfoundland. NL. Okay, we need to go up Yukon. Might not know Yukons. YK. That's what you meant. I totally know. Okay, Northwest Territories you probably know. NWT. And Nunavut, it's probably new to you. It's NV. Nunavut. You might like this unit. Okay, so that's our universal set, and that's how we're going to list our set. So what's a subset? A subset is something that's inside of another set, where all those elements of the subset belong to some larger set. So subset, a set whose elements all belong to another set. One subset of Canada is Western provinces and territories. So we're going to list those. Does anyone know when politicians talk about the West, do you know which provinces they're talking about? BC, Alberta, Saskatchewan, and Manitoba. That's it. That's the West. Yep. It is. MB. Okay. So Manitoba. So we could say, if this is our set of C, we're going to use a lot of Venn diagrams in this unit. W is, would you say all the elements of W are inside C, or C, Canadian provinces and territories? Yeah, sure. Why don't you draw just a small version of it? Okay. So how we would write this is W, this is the symbol for subset. It's like a, kind of like a C, sort of. It's on your formula sheet. So W is a subset of C. So this means is a subset. Or you could also read it as is inside, right? W is inside C. All the elements of W are inside the elements of C. Okay. Now, another thing I'd like to show you is if I ask you N of W, okay, N of W. So what that means is they're asking how many elements are in the set of W. What's the number of elements in W? In this case, it's 4. So N of W represents the number of elements in a particular set. So there's going to be a lot of terminology here in this unit. I'm learning the symbols, and once you get those down, I think you might like this unit. Okay, another one. The complement. The complement is all the elements of a universal set that do not belong to a subset. And we use a little, kind of a, I don't know, what's the word for that? Not a, that's what I was going to say. Is it apostrophe? Yeah? So we use a little, and what it means is not. So that'd be not W. Okay? Everything that's not in W is the complement of W. So that a complement plus the actual set will always equal, when you add them all together, it equals the universal set. Okay? So let's list the complement of W. So everything that's not in Western Canada. Okay, so what are all the elements not in Western Canada? Ontario. What else? Nova Scotia. Quebec. New Brunswick. PEI. Newfoundland. Is it NF? I forget. NFL or just NF? I think it might be NFL, actually. I wrote NL.
What about the territories?
Yep, those included. Everything that's not in the West. So that would also include Yukon, Nunavut, Northwest Territories. Am I missing anyone? Yukon, Ontario, Quebec, Newfoundland, PEI, Nova Scotia, New Brunswick? Looks good. Okay, so that's the complement. The complement, when it has a little apostrophe, it means not W. What's not in it? Okay, Jasmine wrote the set of eastern provinces as the following. So she defined eastern as Newfoundland, PEI, Nova Scotia, New Brunswick, Quebec, and Ontario. Is E equal to the complement of W, or not W? W not. No. Why not? It doesn't include the territories. No, it doesn't include the territories. Okay, list T, the subset of territories in Canada. So what is T going to be then? What are the territories? Yukon, Northwest Territories, and Nunavut. Say that right? Nunavut. Okay, so would you say that is T a subset of C? Is T a subset of C? Do all the elements of T belong to C? Yes, that's true. Is it a subset? So is T a subset of W? No. Right, because W only has Alberta, right? Doesn't include the territories. Okay, then asked, is T a subset of W naught? The complement of W. Yes. So because the territories weren't in the West, that means they are in the complement. Have to be in one or the other. Can't be in both. Okay. So this is just like an introduction so far to different symbols. The empty set. There's two ways to write the empty set. One is this. That was really ugly. Yep. Exactly. Basically, there's no elements in. Right. So the set of fruit is not in our set of Canadian provinces and territories, right? They don't belong to each other. So, right. So I'm going to give you an example. The other symbol, which is one they have on your formula sheet, looks like that. It's like a zero with a diagonal line through it. So explain why you can represent Mexico as an empty set to Canada. So you can write it like this, or we can write it like this. So Mexico is an empty set to Canada. Why? Because nothing. So what is this? What is C? The set of Canadian provinces and territories. Is Mexico a Canadian province or territory? No. So because Mexico is not a Canadian province or territory. All right, turn the page. That's it for the provinces and stuff. Darn. That was like the best part. Okay, so key ideas. When you're drawing, whether you have to draw a Venn diagram, the key is to list your elements. They might describe your elements, but list them out before you put them inside your Venn diagrams. It's really going to help you organize your data and see, okay, are there overlapping? Oh, that is dead. That is horrible. Oh my gosh, time to recycle these. I know, hey? Well, I was going to throw them, but then somebody was going to say, push-ups. Jesse. Okay, so if they have, so for example, multiples of 4 and multiples of 8, will they have some overlapping data? Yeah. And so the stuff that belongs to both sets would go to middle. If the sets are totally separate, so what about like even numbers and odd numbers? We call that disjoint set. That's a new term, disjoint. And we're going to write that down. Okay, so under here, I draw an extra circle in this diagram that you have there. And draw it B. Write it B. Sets are equal if they contain exactly the same elements, even if the elements are listed in different orders. You may not be able to count all the elements in a very large or infinite set. So for example, even numbers is an infinite set. You're not going to be able to count them. But some sets are small and we can count them. And so this is the number of elements in A plus the number in its complement will equal the number in the universal set. Okay, well, so here, like, this is A, And then everything outside, including the B, is not A. So ignore the green circle right now. Okay? So this is A and this is not A. So together, they add to our universal. Right? So this is what's in A, what's not in A. We'll give you your total for the universal set. I want you to draw this B because I want to talk about disjoint sets. And so if two sets are disjoint, okay, the number of A or B is equal to number A plus number B. They're totally separate. So their total number of elements, we just add them up separately. We're going to have to deal with overlapping later on. Be a little different. Yep. Right, in this case. So this formula is different than this. No, this, okay, that, if they're disjoint, okay, so you have A and you have B and they're totally disjoint. The total number of A or B, you could just add the A plus the B because they're separate. Later on, if they're overlapping, you can't just add up the elements of A and add up the elements of B to get your total elements. Why? Because there's overlapping, so you're going to have to subtract the overlapping stuff. Okay? But, so a okay, guys, woo. Okay? So, what I want to talk about are what are disjoint sets. Disjoint sets are sets that are not connected. Okay, there is nothing overlapping. No, exactly. Those were disjoint. No elements overlap. Okay, so your Venn diagram won't have an overlap. They're totally separate. We call that disjoint. We'll get to the adding and stuff later more. That's for another lesson, so we don't have to stress about it. No. Moving on. Okay, Emma drew the Venn diagram. To the right. Yep, there's lots of Venn diagrams here. Okay, guys. Shh. No talk, just stay on track, okay, guys? Okay, so here Emma said, okay, C we're going to make produce, so all of this is produce. F is fruit. S she called fruit you can eat without peeling. And V she called vegetables. Do you agree with her descriptions? Yes? Okay. Now, pardon me? Okay, so, but it's not a fruit, so it's not inside, right? To describe another way, so she specifically said fruit you can eat without peeling for S. Describe another way Emma could define the sets in her diagram. So what if I was just giving you orange, pineapple, banana, apple, pear, peas, corns, carrots, beans, and potatoes? No circles were given. How can we organize our data? Another way. Seeds and no seeds? Yeah? Okay, how about color? Yeah, let's do colors, because seeds can be like, we can debate a lot about seeds. Well, like, how about oranges? Exactly. Okay, so let's do color. Okay, let's do color. So we'll still do C is produce. Okay. So what colors do we have here? Give me a color. Nope. Orange. Okay, what's orange? So O will be orange. Orange produce. We'll make them green. We'll make things less complicated. Shh, guys. Okay, what's orange here? Carrots and oranges. Guys, Brad, come on. Okay, what's another color? Let's use apples as green here, okay? G. So green produce. Yes. Green produce. Okay, so what's going to be green produce here? What? Peas and beans.
Tough question. Is a potato a sweet potato or a normal potato?
We're going to go a regular potato. What else is orange, green? Apples and pears.
Actually, apples is red. Yeah.
No, there is green apples.
Yep, there's also red apples.
Okay, I'm going to tell. This is what I was afraid of. Okay. Let's next another color. What is left over? Yellow. Is pears more yellow or more green? Yeah, green. More green.
Right, yeah, right. I always did the other one.
Yeah. You can put in whatever set you want, guys. It's your call. Okay, what's our yellow produce? Corn. Should we call it brown or orange or yellow? We're going to call it what? Sure. Just for the sake of this. Potatoes. How about pineapple? Do we have that one yet? It's kind of yellow.
Inside is yellow.
It really is. Let's write it in both. Okay, pineapple. Apple. Pine apples in both yellow and green. Why? We're reorganizing all our elements into a different category. Because this is the way she organized it. We can organize it a different way. Yeah, maybe. Okay, did we get everybody? Yeah? We can move. Bananas are, thank you. Bananas, guys. You almost forgot bananas. Bananas. Okay, moving on. Okay, does it make sense that S is a subset of F?
Yes.
Okay, so what's S again?
S is the things you don't have to peel.
Fruit you don't have to peel. Is that a subset of fruit?
Yes.
Yeah. Yes?
I know, right?
And does it make sense that fruit you have to peel is a subset of produce?
Yes.
Yeah, okay, yes. I'm not going to, do you want to write the explanation or should you just say yes? We're good? We're clear? Okay. What are disjoint, so let's list some disjoint sets. Fruit and vegetables. So F and V are disjoint. Who else is disjoint? S and V, yeah.
S is a subset of S, so it's simpler if you just said FS. Yeah.
But no, so you would just say, well, it's a separate set though. It's still its own set. So S and V are still disjoint. Okay? No, you would say them separately. No. We only talk about one set compared to another set. We don't mix sets. So S and V are disjoint. S and V are disjoint. Okay, moving on. F naught, is that equal to V? Yes. In this case, what's F naught? So F naught means not fruit, and if it's not a fruit, then it is a vegetable. Yay. So yes, all non-fruits are vegetables in this example. F naught. F naught, yeah. So that means not fruit. Okay, determine the number of vegetables. 5. Good. What's N of F? The number of fruit. Right. And what's the number of produce?
It's not mixing up sets though, because you're counting the number of fruits, including the
So,
S.
but that's the S are part of F. That's why they're inside.
S of S?
No. Don't say things that it's not the way it is. And you're going to mix people up. It's not how we do it. I'm sorry, Sawyer. But it's just that's not how we write it. In set theory is different than functional notation. It's a different type of math. They're totally separate. Okay, so And so the number of produce. 10. Total number of produce is 10. Okay. List the elements. What does S not mean? Everything you would have to peel. So not fruit you can eat without peeling. So what would, so it could include vegetables as well. So everything that's not an S. So let's list them. Okay, what's not an S? So we have to list the elements. Oranges. What else? Pineapples. We're going back to a seating plan. Next class. Okay, bananas. What else? Peas, carrots, potatoes, corn, and beans. So everything that's not in S. So I could even ask you, yeah? No, fruit that you cannot, like, so the set is fruit you can eat without peeling. That's what S is. Fruit you can eat without peeling. Got it? Okay. Okay, so that's it for this question. Example 2. Okay, making our own Venn diagrams. Yeah, well, you need to face your fears. Okay, so how you want to set up drawing your own Venn diagrams is start by actually listing the elements before we draw the circles. So let's list, so we're looking at numbers from 1 to 40 inclusively, meaning including 1 and including 40. So let's start by listing the multiples of 8. 8, 16, multiples, yeah, 24, 32, 40, up to 40. Okay, multiples of 4. 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. And then multiples of 17. 17 and 34. And we stop because we only go up to 40. Okay, so as we're drawing this, do we have a set that's inside another set? All the elements of one set inside another. Yeah, Brad? Yeah, so all the multiples over 8 are inside multiples of 4. So our biggest set we're going to draw is our multiples of 4. So that's our F. Okay, so let's draw a big circle. And we're going to have to put inside of that will be another circle for the multiples of 8. We'll call that E. F is the multiples of 4. E is the multiples of 8. So if we write something inside E, we don't have to write it again. Because it implies, if I write it in E, that implies that's already part of F. Okay, so let's start by writing our smallest sets. So I'll also bring in, this guy, because he's going to be our multiples of 17. Okay, and so we'll call him S. And everything is the universal. We put a big Q from 1 to 40. Okay, so we'll start with our multiples of, well, our smallest sets. So, and the one that's inside. So let's do S first. So what's in S? 17 and 34. Let's write those numbers inside there. And then we'll do our E. What's inside E? So we have 8, 16, 24, 32, and 40. Now, when I list the multiples of 4 for F, I'd start at 4, but do I have to write 8 again? No, because we already have it inside. So really, It's basically every second one that's not already in here. So 4, then next would be 12, then 20, good, 28, 36, and that's it. Good. Okay, now we still have to list all the other numbers from 1 to 40 that haven't been included, because that's our universal. So let's start up here. So we'll start at 1, 2, 3. Would I write 4 here? No. Then we go 5, 6, 7. Would we include 8? Nope. 9, 10, 11. We would not include 12. There already. 13. Yeah. 13, 14.
No, 14.
Yeah, 14. 15, not 16. And how about 17? No. 18, 19, not 20, 21, 22, 23, not 24, 25, 26, 27, not 28, 29, 30, 31, not 32, 33, how about 34? No, it's in 17. 35, 36, 37, 30, nope, not 36. So 35, 37, 38, yep, 39. And how about 40? No, it's right there. Whew. Okay, so there it is. Beautiful. We did it. So, yay. Okay, so now we can answer the questions. So this is another way I did it. Moving on. List the disjoint subsets. Who are disjoint? F and S. And who else? E and S are disjoint. Okay, just true and false. Is E a subset of F? Is E inside F? Is E inside F? Yes, right? Subset means it's inside. So yes, true. Is F inside E? Is F a subset of E? False. Okay. Is E inside E? Yeah, it is. So it's the same thing, right? All the elements of E are a subset of E. True. Really weird to write that. Okay, F naught. Is F naught odd numbers from 1 to 40? That's odd numbers from 1 to 40. So are there any even numbers in F naught? Looking at this list. Yeah, there is. So that's false. Okay, in this example, the set of natural numbers from 41 to 50 is empty set. True. So in this example, the set of natural numbers 41 to 50 is empty set. Because they're not in our set. So that's true. Yeah? We're going to add it. It's going to help us to work to understand probability. So and then probability is very important, right? Yeah, so we have to get through this unit before we can apply this stuff to probability. Okay, so your homework, if you grab your workbooks, the principles of mathematics, it's 1.1, 1 to 7. So just omit number 8, the last question, the written response. Just to review, remember on School Zone, if you push the click here button, that will bring you to the website. And I have put set theory. You go to set theory, so now the homework solutions are there for today's lesson. So as you're working through, yeah, it ends at 2:11. Okay, so then you can scroll down. If you're working through it, the solutions are there. Wait, no, they'll come up. They're just loading. Yeah, I did. Okay, so just eliminate the written response because it says the library contains blah, blah, blah. So just omit that one.